Tiwari sir, you are there? Okay, let's start our discussion. How many of you drive car? Prabhat, Shravya, Anish?
I'm learning.
Learning. Okay. Learning on which vehicle? Which model of the car?
Wagoner.
Wagoner.
Yes, ma'am.
Okay. Who else? Vinay, roll number 13. Atharu, do you drive a car?
Yes, ma'am.
Yes. Which one?
Wagner.
Wagoner. Okay. How smooth is Wagoner?
Experience is it is smooth.
Little smooth. Okay. How many of you are driving automatic transmission vehicles? Anybody in this group? Have you studied in theory of machines how clutches and gear change mechanism works in an automatic transmission as compared to manual transmission? Have you studied this in theory of machines? Manish? Yes or no? Lokesh? Briefly. Okay. Unless you okay, a brief overview is also good enough, then you can explore on your own. I'm sure you have studied a single plate clutch and multi plate clutch in your Tom 1, and wherein the driver has to change the gears by pressing the clutch, or that is by disengaging the two shafts, then you change the gear and you release the clutch pedal, and the gears are engaged. Whereas in an automatic transmission, the driver is not manually controlling the gear. So how that works and how a gear train works over there. What we are conventionally studying in theory is very basics of gears or clutches or belt drives, which forms the foundation. And whatever is existing in the present world, this is something you have to explore. Nobody in your interview is going to ask you about a spur gear design. But then they might ask you how an automatic transmission is different from a conventional gearbox, which you are expected to know. Am I right, Pradyumna? Okay. The spur gear that we were discussing till last lecture, you have seen that each teeth or each tooth, their faces are parallel to the axis. So what would happen if one of the gear is rotating and another one is stationary and you are trying to engage? What will happen? The moment you try to exchange, try to mesh them, there would be a jerk. Okay, what else? After jerk, Ambika, Nikhil, wear and tear. Okay. Jerk is, how do you know it is jerky? Wear and tear you cannot see, but you know that there will be wear and tear. Heat dissipation दिखता है क्या? Grinding, rubbing, vibration, noise. Yes, this is the answer I am looking for. You know there are vibrations, you know that the engagement is jerky because it will come with a crackling sound where the teeth are parallel to the axis of the shaft. One of the gear is rotating at say 240 rpm, another gear is stationary. The moment you try to engage, it won't engage easily. There will be a lot of noise and vibrations. How to reduce this? What will reduce this jerky action? You're always giving me the answer. Lubricant? Lubricant, not exactly. Not exactly. What else? No. What will ensure that the engagement is smooth? I repeat, in spur gear, by reducing the relative velocity, friction. No. In spur gear, I'm repeating, the face width or the entire width of the tooth is parallel to the axis. How would you synchronize? One of them is stationary, another one is rotating. So after engagement, the other gear starts rotating. How would you synchronize it to bring it to same RPM? उसी के लिए तो हम engage कर रहे हैं. पीयूष, come on, all of you know the answer. You have studied in theory of machines. Changing the tooth shape, yes, this is correct. And how would you change that, Richa? Okay. Enough of torturing the students. Students might say, आप ही बता दो ना, हमें क्यों परेशान कर रहे हो, isn't it? And the solution is helical gear. What happens in spur gear is because this face is perfectly straight and parallel to axis, one of the gear is rotating, another is stationary. So by the time they are engaging, so by the time this entire width of the gear tooth comes in contact here, this is already rotating. So this moves ahead. So can we think of giving an inclination to the face width or the tooth so that it engages at this tip and gradually it engages here while this is still rotating? And this gave birth to the concept of helical gear. So it's by the virtue of its helix angle or by the virtue of its helical shape or the orientation of the tooth that the engagement is quieter as compared to spur gear. It is smoother, it has less jerk, less noise. The first thing that will make you know that this is a smooth vehicle is no noise. Anybody, have you ever been in an Audi or a BMW or Mercedes? Anyone? So you will get to know how smooth those vehicles are and how the design of the gears is so very perfect. Engagement is so smooth. That's what makes it as costly as how much? What is the cost of BMW? Nikhil? Richa?
Yes, ma'am.
What is the cost of a BMW?
Ma'am, model.
कोई भी मॉडल बता दो, खरीदना थोड़ी है.
It starts from 30 lakhs to and also, ma'am.
Okay, okay. So I am anyway not going to buy, so not interested in model. But what I am trying to tell you is why these are costing 30 lakhs above, whereas a Wagoner you would get probably in 4 to 5 lakhs. Yes?
Because it's engine and model, because of its engine and interior, ma'am.
Interior, okay. इंटीरियर
And
कितना होगा? 5 लाख 7 लाख?
ma'am, because it's engine, it's based on its engine, the engine cost will be more, ma'am.
Yeah, so it's not only the engine, it's every component in that vehicle, every component.
Okay.
So design of gears are much precise design of clutch plate, design of engine, design of exhaust, design of differential, everything would be with a much better accuracy, which increases the cost. And ultimate effect is the person who is sitting on the rear seat and there's a chauffeur who is driving. He'll be absolutely comfortable and he can easily pour a hot tea from thermos to a cup full to its brim and he can sip without spilling a drop of it. So that is the level of quietness and the smoothness when you work with, now here for comparison, in a helical gear as compared to a spur gear. So these days, none of the cars or four-wheelers will have spur gears. They will only have helical gears. Spur gears you would find in industries, in factories where there is no motion. They are more like static, but then there is a power transmission role. So these spur gears, they'll be used, as I said, in textile industries, in punching press machines, and such kind of operation. All automobiles will by and large use helical gears, with an exception. Aircraft engines or in aircraft, they will again use a very precisely manufactured with a very high level of precision spur gears, because there noise is not an issue in aircraft. It is anyway extremely noisy and the passenger area is entirely compact, so they are not going to be affected by the noise. But one who is standing out, they can hear the noise. So apart from the smooth engagement and noiseless, the velocity ratio is also much higher. In spur gear, what is the maximum velocity ratio that we can work with? 6. Here, you can go up as high as 10. So if I ask you to design a gear with velocity ratio 10 without mentioning what gear, the moment velocity ratio is above 6, you should understand that this is going to be a helical gear. Then, because these teeth, they are inclined, so the strength also increases because of increase in the B. This we'll see how. So these teeth, they are stronger as compared to the spur gear. And then this angle in which it is inverted or twisted is known as helix angle. Now helix angle will be using alpha for ease. Data book may it is using psi. Different books might use different things or different symbols. The range of helix angle would be 15 to 23. This cannot cross this level or this limit. And the axes in the helical gear, they would be always parallel, and these orientation or this helix angle will be always opposite hand. So there would be one right hand helical gear meshing with a left hand helical gear. Now which one is right and which one is left? How do you tell which one is a right hand gear and which one is left hand gear? Yes. So there is a simple test. A spur gear looks like this. If you are holding your left hand, then if your thumb is in line with the gear face like this, you call this as left hand helical gear. And if your right hand thumb is in line with this, then you call this as right hand helical. So this is in a normal position. You can stretch this thumb to make it parallel, but then that doesn't become left hand helical. So it depends upon the angle of your thumb, which is normally an acute angle, which it is making with your forefinger. This is left hand and right hand. So a left hand will always mesh with a right hand. Is there a chance that a left hand helical gear can mesh with another left hand helical gear? Is there a chance? Harshini? Bhavna? Yes or no? Karthik? No. No. There is no chance that a left hand helical can mesh with another left hand. The answer is yes. These two can, no, not from inside, outside, if their axes are skewed. Skewed is one of the gear axis is like this, another one is having an axis like this, not intersecting, but not meeting at a point. They are parallel, but it is something like this, that this left hand helix and the left hand helix of other gear, they can mesh. So they can mesh with the same hand if their axes are skewed. So this is a very rare and a special kind of application. Again, another question from interview point. Normally the answer would be no, they can never mesh. Okay, going into details, how helical gear is different. In a spur gear, this is how the tooth is shaped. So this is the tooth. And we know that this is the pressure angle. In terms of the face of the tooth and this line, this is the pressure angle, phi t. But since these teeth, they are making certain angle with the axis of the shaft, this becomes the normal plane. So normal plane is a plane which is perpendicular to the surface of this face width. This is the face perpendicular to this. This is known as the normal pressure angle, and this is the pressure angle along the transverse plane. So this plane is transverse plane, and a plane perpendicular to this helix angle, this is known as normal plane. And this angle, which the surface of the tooth is making with this perpendicular, this is, what do you want me to use, alpha or psi as helix angle? Saurabh? This angle is helix angle. Alpha, okay. Alpha is easier. Alpha बचपन से use कर रहे हैं, it seems he is more close to us than psi, right? Okay, so this is the pressure angle in the transverse plane, and this is the pressure angle phi n in the normal plane or on the normal surface. So this is pressure angle in the normal plane, phi n, and this is in the transverse plane, phi t, where this angle is alpha. So can you now give me a correlation between Pn and Pt in terms of alpha? Quickly. What is the relation between Pn and Pt? Where P is the pitch along the transverse plane. Pitch is the distance between a given point on the gear tooth to the corresponding point on the adjacent gear tooth. This is the pitch. So what is the relationship between pitch in the normal plane and pitch in the transverse plane if this angle is alpha? Quickly, please. Pn is equal to Pt into cos alpha. And the same relationship will be there for module. So normal module will be transverse module times cos of alpha. This equation will be using for designing the gear. Now if I talk about the forces coming on it, now this is as good as a spur gear, and on a tooth, what is this force and what is this force? We call this as, अभी जो हमने स्पर गियर में किया था, what is the force along the radial direction? What is the force perpendicular to the surface? This is Ft and Fr, correct? Where this angle is pressure angle. This angle is the pressure angle. Now because of this particular orientation, here there are two more forces. The same thing if I can represent here, this is my Ft, and at the same point there is a component of axial force coming into picture, Fa. Such that this angle which their resultant is making with Ft, this is alpha. The resultant of Fa and Ft is making an angle alpha with Ft. Similarly, resultant of Fr and Ft is making an angle phi t. Now we have to get a relationship between what is this axial force, what is the radial force, and what is this Ft, the static force responsible for transmission of power. Everything in terms of phi t and alpha. So a radial force is, allow me to draw a rough figure here. What is this force? Assuming there is a gear tooth here. This is the radial force acting along the radius. This is Ft force acting perpendicular to the radius. And on this plane, on this surface, there is this Fa force acting along the axis of the shaft. A force which was missing in case of spur gear. And this is the radial force Fa acting along the radius. For representing all these three forces on a single plane, I am using this block. So if this is my gear, here there is a shaft, then the force acting normal along this is Fr. The force acting Ft is acting such that this drives or rotates the gear Ft. Which line is showing Fa? This horizontal line is Fa. This force along the axis of the shaft. This is Fa. This concept is very important, so I want you to be very attentive here. Same force, let me mark it here, Fa. So what is the angle between this Fa and Ft? What is this angle? Atharva, what is this angle? Not 90 degree. This is the resultant of Fa and Ft. Alpha. This angle is alpha. And I'm not asking you the angle between FA and FT. I'm asking you the angle between the resultant of FA and FT, which it is making with FT. This is alpha. If this is FT and if this is FR, this is FR, what is increase the size? I don't know how clear this image is. So if this is FT and this is FR, this yellow dotted line is showing the resultant between FR and FT. And what would be this angle? Phi T. This is the pressure angle in the transverse plane. Now if I want the resultant of FA, FR and FT, this is FA, this is FT, this is the resultant, and the resultant of this force FA, FT ka resultant and FR. So this is FR, so this can also represent FR. So the resultant of FA and FT, this blue dotted line, and FR, iska resultant would be this solid bold line. Can you see this line? This is the resultant, which we'll be calling as Fn. Can you tell me what will be the angle this Fn is making with the resultant of Fa and Ft? What will be this angle? Vaishnavi? So the resultant of Fa and Ft, this is blue dotted line, and Fr, resultant of these three forces is Fn, which is making an angle phi n. Perfect. So this angle is phi n. Now if you can tell me the relationship between these three forces. What is Fa by Ft? Fa by Ft? Tan alpha. Perfect. What will be Fr by Ft? Fr by Ft? Tan phi t. Good. So what is the relation between Fn and Ft? Let me use the same space. Fn and Ft. Fn Ft. Come on, I'm sure all of you are very good in trigonometry. Only cos phi t. Cos alpha into sin phi n. Ft cos alpha into sin phi n. Okay, there can be different relationship. Can I write Fn as Ft upon cos alpha into cos phi n? Yes, cos alpha into cos phi n. Ambika, please check. Yeah, is that correct? Now give me the relation between phi t, phi n and alpha in terms of sine cos phi, sine cos tan. Give me a relation between phi t, phi n, alpha. Quickly. Yeah, anybody is giving me the answer? Relation between phi t, phi n and alpha independent of these f. Sarthak? Surya? Sai Sagar? Manan? Yeah, give me the answer. Siddesh? Okay, nobody is giving me the answer, I'm assuming. So this happens to be cos alpha is tan phi n upon tan phi t. Perfect, Athar. Good. Good, good. Same thing I am writing as tan phi t is equal to tan phi n upon cos alpha. Or cos alpha is equal to tan phi n upon tan phi t. Summation is 180. Okay. And efficiency of the gear of a spur gear is again almost 97 to 98%, which is if pinion is driving a gear, this will be defined as work done at the gear upon work done at the pinion. So work done at the pinion, because this is the input gear on the input shaft, will be always larger than the work done at the gear. So in each pinion to gear transmission, there would be 2% loss, and this loss of heat goes as what? What happens to this 2%? This 2% is the heat loss. This energy goes as heat. Yes. Now another question for interview again. Why for the same pitch a helical gear is stronger than a spur gear? Why for the same pitch a helical gear is stronger than a spur gear? So answer lies here. Look at the thickness of the gear. This is the width. In a spur gear, the thickness would be like this. This one would be the thickness. In case of spur gear, the thickness B of the face width we are measuring here. Whereas in the spur gear, now this B is this. So now the thickness in the transverse plane, this is in the transverse plane, this is in the normal plane. And what is the relationship between these two? So it is the thickness of the tooth. Yes. In the transverse plane, is 1 upon cos alpha times its thickness. It's for the helical gear. Is 1 by cos alpha times the thickness of the spur gear. Everything remaining the same. The module could be same, the pitch could be same. But this is because this makes a helical gear of same pitch stronger than the spur gear. Now coming to the design of the helical gear. Now you have seen that the design of spur gear, we are using Lewis equation, and then we calculate what is the static load from the bending strength or the beam strength of the gear tooth, and then we go for the Buckingham equation to find out what is the incremental load and what is the static load. We sum them, then we find what is the wear and what is the endurance strength. If we want to use the same formulas for the design of helical gear, then there has to be some equivalence. So can we find out what is the spur gear equivalent of helical gear? Which means if in a helical gear the number of teeth are 20, then it's equivalent. This is equivalent to, suppose, a spur gear of number of teeth 24. This is just an example. If the number of teeth in the helical gear is T1, this should be equivalent to a spur gear with number of teeth T2. And if we can find out this equivalence, then we can use the formulas as it is, the formula that we are using for the spur gear. So the only difference in the design of spur gear and helical gear is we have to get this equivalent number of teeth, which is known as the concept of formative number of teeth. Formative number of teeth. Atharva, what do you understand from the formative number of teeth? Atharva? So formative number of teeth is giving the spur gear equivalent of a helical gear. So if you are using the formative number of teeth as number of teeth in all those formulas where we are using the Lewis form factor, some term minus something upon t. So instead of t, if we use tf, formative number of teeth, then that becomes the formula for the helical gear. So how do we get this equivalent number? This is slightly important. If I go with a tooth and if I cut it along its section, give me a minute. If there is an intersection of this normal plane and this is the pitch circle diameter, this I am taking a section of a tooth where this is the axis of the shaft, this is the radius of the tooth. So if I cut this pitch circle diameter or the pitch circle with the normal plane, any cylinder you cut with a straight line and you know that the section will be an ellipse. You agree? Aren't your mics working? I don't know why there's a delayed response in the chat. Nobody's interacting. This is an ellipse And this would be an ellipse whose major axis would be, if this is r and this angle is alpha, this angle would be r upon cos alpha. If the radius, pitch circle radius is r, or it is d by 2, if I can take its minor axis, this is RE, and if I draw a circle with this minor axis as my radius, I'm drawing a circle with radius equal to radius of the minor axis of the ellipse, which is obtained by cutting the pitch circle with its normal plane. Then on this circle, whatever number of teeth can be generated, that is known as formative number of teeth. And this RE, I'm not going too much into the details, but this happens to be the major axis radius if the major axis is 2a and if the minor axis is 2b. Then the radius of this circle and its location, this is normally given by a square by b, where a is r upon cos alpha whole square and its minor axis is r. So re is my equivalent radius of the circle which I am drawing with the minor axis of this particular ellipse. This comes out to be r upon cos square alpha, which is written as, if the pitch circle we are representing by d, it is d by 2 cos square alpha. This is that equivalent radius of the circle. I'm repeating, you can take down if you want to write down what is the formative teeth by definition. Formative number of teeth NF, normally given by NF. This is a number of teeth that can be generated on a virtual cylinder with radius of the minor axis of the ellipse, and the ellipse is obtained by intersecting the pitch circle of the helical gear with its normal plane. So this forms an imaginary spur gear whose pitch circle diameter is 2 times of Re and whose module is Mn, the normal module, for which the number of teeth is its circumference upon the pitch. Pitch is the distance between any two adjacent teeth in the normal plane. Circumference of this circle is 2 pi Re upon its normal pitch Pn. So Re I am writing as 2 pi d by 2 upon cos square alpha into Pn, and Pn is in terms of Pt, this is pi d. Pn in terms of Pt we have just seen, this is Pt cos alpha into cos square alpha. Pn is written as Pt cos alpha, and this becomes pi d by Pt upon cos cube alpha. What is this pi d by pt? For a gear with pitch circle diameter d and the pitch distance between any two adjacent teeth as pt, what is pi d by p by definition of pitch? This is equal to number of teeth t upon cos cube alpha. So you take it down as tf, or in few books it is mentioned as nf. So the formative number of teeth, I am repeating, this is the equivalent number of teeth on the spur gear, assuming we are replacing a helical with spur gear. So in the design of spur gear, we are using minimum number of teeth on pinion as 25. So in case of helical gear, when you are using 25 for calculation of Lewis form factor y, will be using as 25 upon cos cube alpha, where alpha is whatever helix angle is given in the problem, 18 degrees, 20 degrees, 21 degrees. So all that you have to understand is, instead of going into details, you have to understand that the equivalent number of teeth on the spur gear is the actual number of teeth on the helical gear that you are assuming upon cos cube alpha. So TF will be greater than T or less than T? TF will be greater than T or less than T? This will be greater than T. And the advantages of this is, can you tell me what is the advantage apart from whatever I am mentioning? Undercutting reduces, teeth are stronger, yes. You can have lesser number of teeth. Lesser number of teeth. For spur gear, you have to have 25. Here, even if you go with 22, this 22 by cos cube 18 degrees, this is going to be almost 24, 25 or even more than that. So the manufacturing cost goes down because you have to cut lesser number of teeth to get the same strength. Or with more number of teeth, you are getting stronger gear which is stronger in bending or fatigue. Or for the same strength, you can have lesser number of teeth. So this is another comparison of helical gear and spur gear. For the same strength, you can have lesser number of teeth cut on a helical gear. So tomorrow, maybe next class, we'll start with the design. So instead of T, we'll be using TF or NF. Face width B will now be the transverse pitch PT upon tan of alpha, where alpha is the helix angle. The transverse pitch in terms of module is written as pi mt upon tan alpha. Normally here the face width is slightly increased, and it is increased to almost 1.3 to 1.5 times. This also ensures the smoothness in the engagement. So engagement becomes all the more smoother, and so the face width is taken as 1.5 times pi mt by tan alpha. Pi is almost 3.14. So if I take pi as 3, so this is 3 into 1.5, which will come out to be 4.5 approximately. So this is pi is taken as 3 times mt. We are additionally increasing the face width by 1.3 to 1.5 times to make sure that this is stronger. And so the face width B is taken as 4.5 times mt by tan alpha. So what is the advantage of larger face width or the larger value of mt? Why we are increasing this is, by this 1.3 to 1.5 times. This is the teeth on the surface. This is the axis of the gear. While the gears are meshing and the load is shared, this is the longer distance which is sharing the load. When the load is getting transferred from the one tooth to another tooth, there's a longer area of contact or a longer length of the tooth which is in contact. And so instead of the spur gear where at a given time it is 1.7 to 2 number of teeth in contact, here we get more number of teeth in contact. So the load is shared by more number of teeth. So as you increase the value of MT, the load sharing increases, or load is shared by more number of teeth. That is the advantage of increasing B. It is not having surface contact. Ideally, it should have a line contact. But that line is continuously changing and it appears like a surface. The surfaces are like this. I don't know if I'll be able to draw it perfectly right. Yeah. So ideally, it should be a line contact. So it is known as higher pair. Pointer line is known as higher, right? Okay. So this is promoting load sharing. This is indicating a better overlap. And the value of alpha, if the range is given as 18 to 23, alpha should be lower. If alpha is higher, then the value of B minimum, this is the B minimum value, this 4.5 MT by tan alpha, like there in B minimum was 8.5 M, here B minimum is 4.5 MT by tan alpha. If you increase alpha, what will happen to B? To increase or reduce? You increase alpha, what happens to B? B will reduce. If you increase the value of alpha, B minimum will reduce, and with the decrease in B minimum, this axial load, now this axial stress or the axial force is unwanted. This increases. This is undesirable. And so we'll try to keep this alpha minimum. So alpha minimum is in the given range, it is normally 18 to 20. Will not go on the higher side. One more concept in last 5 minutes, because students have asked me to leave the class at 55. The value of CV. What do you think? The value of CV in helical gear should be lesser than spur gear or more than spur gear? Use a proper logic. Incremental load because of vibrations is to be taken care by CV. CV should be less or CV should be more in case of helical gear as compared to spur gear. Quickly. Less. What do you understand by value of CV? If in case of spur gear CV is 0.3, which means the beam strength is only 30% of the actual. Here if you reduce it to 0.2, it means the beam strength should be only 20% of the original, which means the incremental load unwanted is 80%. I don't know if you're getting me. In case of helical gear, we are saying less noise, less vibration, it is smoother in operation, which means what? The dynamic load would be less, which means the incremental load would be less. So you have to reduce the face width by a lesser amount. So what should be CV? More. Is that clear why it should be more? Vaishnavi?
Ma'am, can you repeat the reason?
Yes. Just let me write the value of CV. This is 0.45 and this is 0.4. What were the values of CV in case of Spur gear? It was 0.3, 0.25, 0.3 and 0.4. What is the significance of CV? This is very important. S naught Y M B. This is the beam strength. This we are equating with FT because Fi is not known. To take into account the incremental load, we multiply it with CV. If the value of CV is 0.3, what does that mean? It means we are taking only 30% of beam strength and 70% of the strength goes in waste because of the dynamic load, the vibrations or the incremental load. Now since helical gears are smoother in operation, so the incremental load, the unwanted load or the dynamic load value goes down, which means now instead of 30% of the beam strength, we can consider this as 40% of the beam strength or 45% of the beam strength. So we are taking the value of CV for helical gears larger than the value of CV for spur gears. Another very important concept. Think on it. If it is not clear, we'll again discuss in the next class. This Saturday, I am again going to engage the class. I don't want to give a break for 1 week, and so this Saturday we can discuss this again if this part is not clear. Anybody has any doubt? Next 2 minutes for you. Prajwal? Shriya? Any doubts? Rishikesh?
Ma'am, can you please repeat it in next class also? This
Yes,
part.
I will. I will,
Yes.
but I want you to try to understand the difference between helical gear and a spur gear. Daitwa?
Yes, ma'am.
Did you understand why CV for helical gear is larger than spur gear?
Yes, ma'am.
Yes. Can you explain me in one statement? Daitwa. Daitwa, waiting for your answer.
Ma'am.
Say no if you're unable. It's okay. Because you said yes, that's why I'm asking you. Roll number 44, Ram, you are there? You do smooth motion, less incremental load, so beam strength can be taken more, and so CV is more. As simple as this. Pradyuman is giving me the answer. And he says in one line, due to smooth motion in helical gears, less incremental load, and so the beam strength can be taken more than the spur gear equivalent. So Ram and Devesh, are you there? 44, 46. Devesh is there, although I cannot hear your voice. Devesh?
Yes, ma'am.
Yeah, what yes? Did you understand the significance of CV?
Yes, ma'am. I understood it, but I will study it once more.
Okay, good. Deepika?
Yes, ma'am. Like I'll study myself once.
Okay. study yourself once. Okay, thank you. Anybody has any other doubt related to helical gear? Okay, thank you.